Caspian Sea is the largest lake on the Earth. The northeastern part of the sea, adjacent to the shores of the Republic of Kazakhstan, is highly sensitive to significant changes in the sea level. The Caspian Sea level falling and its shallowing in the area of NCOC's Kashagan offshore production facilities limit considerably the navigation capabilities. For this reason, in 2022, it became necessary to dredge the seabed along the marine navigation routes, particularly the shallow areas of the existing routes, to ensure vessel access to the NCOC offshore facilities and evacuation of people in case of emergency. The length of the marine navigation routes in the direct approach section to the NCOC islands is 32 kilometers, and 24 kilometers between the islands. The total area of the navigation routes is 29 square kilometers, which accounts for less than 0.36 thousandths of a percent of the entire North Caspian Sea area. Currently, the marine navigation routes are the only and primary communication network in the offshore logistics chain. Recent years saw a noticeable trend of the Caspian Sea level falling. The average annual sea falling in the past 4 years was over 20 centimeters per year. Despite the 2024 flood in western Kazakhstan and additional measures taken by the state authorities to increase freshwater flow into the Caspian Sea, the rates of the sea level falling remain to date. Also, over the time, the natural siltation of the navigation routes occurs due to intensive sea level falling, wind-induced waves, and surge events, leading to decrease in the design depth. Forecasting the Caspian Sea level is, oddly enough, both a very complex and a very simple task. In what sense is it simple? The Caspian Sea is a landlocked water basin. Hence, unlike any certain water areas, for example, the ocean, it is easy to calculate the balance. This means that if we know how much water is flowing in and how much is flowing out, we will know exactly how the level behaves. The problem is that we don't know it, and therefore, we don't know how these components of the water balance will behave in the future. The inflowing part is from the rivers. How much water inflows from the rivers? More than 80% from the Volga, while the other rivers account for less than 20%. Plus, precipitation that falls directly on the sea surface, a smaller component, yet also significant. Sometimes they also say that there are some underground waters, but if it's true, then this makes a very small portion, and the outflowing part of the water balance, in my opinion, is evaporation. What is the reason for a bottom sedimentation removal operations along the marine navigation routes?
Removal of sediment is an engineering operation aimed to remove sediments from the bottom of the channel. Sediments like sand, silt, clay, and other sedimentary rocks from the channel bottom to reach the designed project depths required for the safe navigation of the fleet, our vessels and barges. This operation is a standard practice in oil and gas and marine industry. That ensures the vessel's safe navigation and to ensure the pipeline operation, protecting the underwater structure, and also it is for reinforce our channel falling from further siltation. Currently, uneven accumulation of the sediments along the channel and as well as falling Caspian Sea level effect, which will cause serious restriction for our navigations, including inability of our fleet to provide supply chain for materials, spare parts, and food delivery, and also wastewater removal from offshore. That's also restrict us for emergency evacuation, emergency response for any situation offshore at Kashagan, for well intervention activities, for example.
In 2019 to 2020, the company conducted the baseline environmental surveys in the entire area of the intended dredging works. These surveys allowed studying all components of the marine environment, including food stock and migration routes for fish. Since the start of dredging operations in 2021, the impact monitoring has been carried out in all seasons except for winter. During the period of 2023 to 2025, additional post-dredging monitoring of biota and bottom sediments restoration was performed. The environmental monitoring was mainly focused on the seawater, microbiology of bottom sediments, aquatic vegetation, phyto and zooplankton, macrozoobenthos, fish, birds, and seals. The results of the seawater studies show that the physical and chemical parameters were within the optimal limits for aquatic organisms. Critical turbidity levels were observed only in the immediate vicinity of the dredging site and did not exceed the maximum calculated levels of the environmental impact assessment. Quantitative parameters of phytoplankton and zooplankton vary significantly. After completion of the dredging activities, it was confirmed that the biota population was higher than the baseline values. Analysis of macrobenthos confirmed that the seasonal trend of indicators has fully restored and was entirely consistent with the trend of similar benthos indicators at long-term monitoring stations. This demonstrates a natural process of decline in population and biomass, which covers a significant part of the biocenosis of the northeastern Caspian Sea. It is also worth noting that as soon as the physical impact of the dredging activities stopped, the birds and seals returned to the area. Within 2 years, as compared to 3 years of the conservative impact assessment, the biota in the dredging area has completely restored to the baseline values of the North Caspian Sea.
Long-term monitoring surveys conducted in the navigation channel area from 2019 to the present cover all key components, parameters of the marine environment. Monitoring includes observations of the condition of zoobenthos, phytoplankton, zooplankton, microbiota, ichthyofauna, as well as seawater, the marine sediments. The same regular surveys have been carried out across the entire northeastern Caspian Sea area since the mid-1990s, starting from the initial stages of the Kashagan field development. The results of the monitoring studies have been confirmed in the forecast data presented in the previous environmental impact assessment. No long-term or irreversible impacts on marine flora and fauna have been identified. Recovery of benthic communities and the return of phytoplankton, zooplankton indicators to the baseline background levels have been observed. Hydrochemical, hydrophysical parameters of seawater and the bottom sediments remain with a range of natural variability. Reasonable assessment of the impacts of the planned dredging repairs has been carried out based on the comprehensive analysis of the obtained data, taking into account the results of previous stages and the environmental baseline conditions in the design stage. Therefore, the applied approach ensures the scientific validity, environmental balance, and the legal validity of the assessment and the compliance with requirements of Environmental Code of the Republic of Kazakhstan, as well as International Environmental Impact Assessment Practice.
Marine navigation routes are located outside spawning and migration areas of sturgeon and other species of migratory commercial fish, and do not affect fishing areas, birds' migration routes, and nesting areas, or Caspian seal concentration and pupping grounds. Sturgeon species avoid the area of disturbance and come back after completion of the works. The underwater berms will not become an obstacle for fish migration. Thanks to the design solution, fish will be able to bypass obstacles both along the top of the berms and from the sides. The berms are located in a staggered order along the navigation routes at the distance of up to 2 kilometers from each other. One of the most persistent misconceptions is the idea that dredging is a destructive practice that causes irreparable damage to marine ecosystems. In reality, modern projects undergo multi-stage environmental control and are implemented in accordance with strictly regulated international standards. According to environmental mapping, the areas for bottom dredging and cleaning, production and transportation at Kashagan do not overlap with spawning grounds, fish migration routes, or mass stopover sites for migratory birds. These areas are excluded from the project geometry as early as at the feasibility study stage. This is confirmed, inter alia, by independent review reports from the scientific research centers involved in biomonitoring. It is noteworthy that the long-term scientific research into the state of the marine environment, including monitoring of benthic fauna, water chemistry, sediment trend, and biodiversity, has been conducted in the exposed area by Kazakhstani and international institutes, including INISEM, Institute of Oil, Gas, and Environmental Research, and third-party laboratories.
The dredging is performed in a small scope, and the route maintenance, currently under discussion, covers a small area. Small volume of removed soil will have a minor impact on migration of sturgeon and fish in general, as the channel itself is located in shallow water, while sturgeon like deeper habitats, and to a large extent, they migrate for spawning to the Volga and the Ural rivers. There is another issue with sturgeon. First, it is the over-control of the inflow, particularly from the Volga River, where dam construction has practically cut off a major part of spawning grounds for sturgeon, with beluga losing all its spawning grounds, and stellate sturgeon to a larger degree. In other words, dams have blocked sturgeon migration routes, or the movement of sturgeon to their spawning grounds. Thus, natural reproduction has sharply decreased now. Hence, Kazakhstani fish hatcheries are trying to somehow replenish this population. However, the ratio of natural reproduction that was before the construction of the hydroelectric power station, for sure, is non-recoverable. In my opinion, over 100 million sturgeon youngsters need to be released from hatcheries, and then we may somehow increase the sturgeon population in the Caspian Sea. And second is the illegal fishing of sturgeon and poaching widespread throughout the Caspian Sea. In the Volga Delta, from 14 to 15 millions are removed annually, and every year the Volga-Caspian Canal is dredged for navigation. So this will not cause any particular harm, especially as the company compensates the costs by investing in the development of the measures to protect flora and fauna of the North Caspian Sea.
Мероприятий, связанных с охраной растительного животного мира Северного Каспия.
Considering all alternatives, risks, opinions of experts and scientists, and best international practices, it was decided to dump the soil within 540 meters from the center line of the navigation routes. Sedimentation removal works, as opposed to dredging, involve solely the removal of local silt deposits without changing the design depth formed during previous dredging operations. The advanced cooking pot technology will be used for sediments discharge onto existing berms. It effectively reduces the spread of small particles during soil disposal, thus creating a dense flow. The generated mixture of bottom soil, water, and air, the so-called slurry, enters the cooking pot. Here, the slurry gets rid of the air, which bubbles up and releases into the atmosphere. Such process results in increased density of mixed water and bottom sediments, making the slurry thicker, heavier, and it settles to the bottom, forming a dense dump. The technology is aimed at significant decrease of turbidity during the operations, which consistently reaches 90%, depending on changes in wind and current.
To
some extent, this has a negative impact on turbidity during dredging. Of course, with soil removal, the turbidity of water increases, and suspended solids can reduce photosynthesis for phytoplankton. There is a direct and indirect impact, as water turbidity reduces water transparency and sunlight penetration. These are the primary conditions for green plants and phytoplankton to develop and produce their own kind, which will then be consumed by zooplankton and fish. However, in terms of the scale of the current route maintenance, this is a small scale. Moreover, as scientists' research has shown, the restoration will take place within 2 to 3 years. Bottom organisms, mollusks, and various worms that inhabit the area during these years will restore. Phytoplankton and zooplankton will restore faster. Thus, after the dredging completion, the turbidity settling allows green plants and planktonic organisms to develop. The project has been developed in accordance with all requirements of construction norms, the Environmental Code, and the Law on Specially Protected Natural Areas of the Republic of Kazakhstan. As a future alternative to overcome falling Caspian Sea level logistics and evacuation risks, and minimize impact of dredging activities, there is a project for construction of a road from onshore facilities to D Island in phases is being developed, subject to approvals from the relevant authorities and shareholders. The phased land link project, Phase 1 and Phase 2, involves the sequential construction of the road in alignment with the declining water levels. This approach minimizes environmental impact, reduces the need for marine navigation routes, and offers flexibility to adapt to future fluctuations in water levels. Phase 1 of Land Link project consists of the construction of an onshore road from Samal Camp to the approximate shoreline. The subsequent connection from the Phase 1 onshore road and the offshore facilities at D Island will be provided by amphibious vehicles. Amphibious vehicles have minimum environmental impact in the open sea. Phased construction provides flexibility with water depth variations. Given falling Caspian sea level, this option minimizes environmental impact while maintaining Kashagan operations. Phase 2 of Land Link project includes road extension from the coast to offshore facilities. As the water recedes, Phase 2 involves further road and potential causeway construction from the shore to Kashagan offshore facilities.
Indeed, different forecasts have been published. Unfortunately, there is no consensus on the long-term forecast in the scientific community. Many people are engaged in such works, however, with no consensus forecast. There are various forecasts, some of them are very alarmist. In particular, widely known works published in recent years with the forecast for the falling Caspian sea level by 18 meters by the end of the century. Should this be true, it would be indeed a major problem or a disaster, because in such case almost the entire North Caspian Sea would dry up, and this would cause very serious socio-economic and climatic consequences. However, most of the scientific community believes that these forecasts are incorrect or exaggerated. I also support this view. They do not consider a number of feedback loops that will limit the process of further level decline. There are other, more reasonable, in my opinion, forecasts indicating further falling sea level in the next decades, however, not at such rapid rate, and stabilization is forecasted somewhere in the middle of the century or in the 40s, maybe earlier. The total extent of the falling sea level by this time is being debated, but most likely it will be 1 to 2 to 3 meters as maximum, which will not cause the entire North Caspian Sea drying up. The point is that the drying up of part of the North Caspian includes a strong feedback loop. The sea surface area decreases, and accordingly, evaporation decreases. Therefore, I do not believe that the North Caspian Sea can dry up completely, or for the most part. I think that in the coming years, in the coming decades, or maybe even years, we can expect stabilization at some level not so different from today's, and then the level may probably rise.